Here we have a radical equation that actually has a radical inside the radical, which just looks gross. My advice is don't panic. Just pretend everything is fine. Okay, stick to your training. Remember what we have to do first. First step is isolate the radical. Okay, that's always what we're trying to do first. Once we have the radical isolated, we can simplify things by getting rid of it. The question becomes in this one, which radical do we isolate? Do we isolate this big radical over here? Or do we isolate this big radical or this teeny little radical over here? I would recommend do the complicated one first. Isolate the complicated radical first, because that way you deal with the biggest problem up front. It's actually better to get the big problems out of the way. So at least it's already isolated for us. That part is nice. So we're going to take this equation and say square root of delta plus 1 equals the square root of 7 plus 2 radical delta inside a square root sign. And now we're going to square both sides. Square that, and I have to square the entire left side. Remember, we're squaring the entire side of each equation. Now, the right side becomes simple quickly. That squared cancels out with this radical. Okay, and what you get is just the radicand, 7 plus 2 radical delta. But the left side does not simplify quite so easily. It's going to be a little more lengthy. Think about what this means. This means square root of delta plus 1 times the square root of delta plus 1. Okay? And that means you have to do foiling. First, outer, inner, last. Remember that from polynomials? So we're going to do square root. You know what? Let me grab some different ink here. I'm going to do square root of delta times the square root of delta. Okay, next thing we're going to do, let's just keep track of all our terms, where they're coming from. In orange, we've got plus 1 square root of delta. And then we have the inner terms right here. That's another plus 1 square root of delta. And the last term is this, it's the last term, right? FOIL. So that's going to be 1 times 1, so that's plus 1. And there we go. There is our foiled equation. We're not done yet, but I think the hard part is over. So simplify all this. Square root of something squared just makes delta. Plus 1 delta and another 1 delta, that's going to make 2 square root of delta. Plus 1 equals 7 plus 2 square root of delta. And look at this little treat we have here. We can do minus 2 delta from each side, and those square roots just disappear. So in the end, we're going to have delta plus 1 equals 7, and delta equals 6. So that's simplified pretty quickly. Now, let's just take a look at the original equation. I'm going to grab that guy and bring it down here, because we always need to remember to check our work. If you don't plug your solution back into the equation, you may end up getting something that doesn't work at all. And I'm not going to go through and solve this thing, because the square root of 6 is really hard to do. But what I am going to do is just check for the possibility of extraneous answers. Okay? And what I mean by that is, let's make sure that none of the radicands are 0, or negative 1, or negative 2, or any negative number for that matter. Okay, so 6 is a positive number. That's okay. 2 radical 6, that's also positive. It's messy, but it's positive. So this radical is going to be okay. And if you want to be very sure that this thing actually works, this is the point where you would have to plug it into a calculator to see for sure. And let's just do that for the sake of argument here. Square root of 6 plus 1 is equal to, where's my pen? Give me my pen back. 3.45. And 2 square root of 6 plus 7. And then, okay, so 2 square root of 6 plus 7 is 11.899. And the square root of that is, oh, look at that, 3.45. Great.